In this example, we are going to use the raster method to describe these different sets here. So it says for a letter A here, it says set F is the set of integers less than 3. So now we're going to use the raster method to describe that F. Here we have a word description. So now we're going to use the raster method to describe this same set. And remember that the raster method goes ahead and lists all the elements in the set. So for A, we'll just say set F. We still use those curly braces. Now these are the integers less than 3, so I'm going to have an ellipses that starts it off. And then, of course, we go ahead and we make a pattern, establish a pattern here of all the integers less than 3. So maybe I'll do something like -3, -2, -1, 0, 1, and 2. And then I'm going to go ahead and close off my ellipses here. So here's the raster method listing all the elements of the integers less than 3. For B, we have set A as the set of rational numbers between 1 and 3 inclusive. Now the word inclusive means including 1 and 3. So I'm going to use the raster method, and the raster method means we have to go ahead and list everything. So maybe it'll be something like set A, and then I'm going to list everything. Now it has to include 1 and 3. Now rational numbers are all the ratios that we can list. So if some students may put down 1, and then they'll do ... ellipses, and then they'll put in 3. However, I think this is incorrect, or this is very misleading, because one of the things about the raster method is before we can use an ellipses, we have to be able to establish a pattern. So using just one element to start the pattern isn't good enough. So it's hard to tell what the ... should be here. Because what is the next largest number greater than 1? Well, would it be 1.1, or would it be 1.01, or would it be 1.001, or 1.0001? So in other words, we can't get a pattern established here. So I don't think we can describe letter B here using the raster method. We can use the set notation method. For set notation, I guess we can say set A is the set of all elements, and maybe I can say R, and I can say such that R is an element of the rational numbers, and that's labeled with this box text of Q. And then I can say and R is greater than or equal to 1, but less than or equal to 3. So I can use set notation to describe this word description, but I don't think we can use the raster method to be able to describe it. So I don't think the raster method works for this one. It's too misleading. So it doesn't work here. Letter C, set S, which is the elements X, such that X is an element of N, which is the natural numbers, and X is greater than 100. So I'm just going to go S, and I'm going to list all the natural numbers greater than 100. So that's going to be 101, 102, 103. And again, once we have a pattern that's been established, we can then go ahead and use our ellipses to show that that pattern continues. For D, set T is all the elements X, such that X is an element of Z, and Z is an integer, and X is greater than -4, but less than 5. So I'm going to put in T. Again, don't forget the raster method lists all the elements. So I think we can do that. It's going to be all the integers greater than -4 but less than 5. So I'm going to put in -3, -2, -1, 0, 1, 2, 3, and 4. And then finally for E here, set O. And you could see for here, this is a word description. We have another word description. Here we have set notation. For D, we have set notation. And for here, we have another word description. And of course, it says set O is the set of odd integers. So O, and I'm going to list all the odd integers. And of course, integers also include the opposites of the natural numbers. So I'm going to put in maybe an ellipses here. -7, -5, -3, -1, 1, 3, 5, 7, and then carry my ellipses as it continues on. So here we went ahead and used a roster method to describe either a word description here or the set notation. It doesn't always work, as we can do for B. That's why we have different methods, because one method may be more clear or might not work than another method. And there you go.